Thank you for being here, and thank you for those tuning in online for being here. It's a great pleasure and honour for me to introduce two of our three speakers today, Gerald and Roberta Schorr from Rutgers University. Unfortunately, Lisa cannot be with us, but she has been part of the work that Roberta and Gerald are going to talk about today. For those online also, you can follow the presentation. There's a link to the PDF of the slides available at the page where the abstract is. Okay. I just want to give a brief introduction to our two distinguished guests and scholars here today, both of whom I've known for a very long time, and I'm very proud and honoured to have you both back here at the Kaput Centre. I'm very excited about hearing the latest advances in your important work. Roberta is an Associate Professor in the Department of Urban Education, Faculty of Arts and Sciences at Rutgers University in Newark. She's a member of the PhD faculty of the Graduate School and Graduate School of Education at Rutgers University in Brunswick, and an affiliate member of the Department of Mathematics, Computer Science at Rutgers, Newark. Roberta's research is focused on professional development, assessment, technology, policy, and the development of mathematical ideas in students in pre-K through graduate level education. The purpose of her research and work is to expand the number of students who are able to acquire the knowledge and abilities that are needed to be successful and productive in a democratic society. Welcome, Roberta. Gerald Goldin is a member of the graduate faculty in mathematics, physics, and education at the Graduate School of Education at Rutgers University. He's also a member of this, he is also a member of the Center for Discrete Mathematics and Theoretical Computer Science, and an associate at the Center for Mathematics, Science, and Computer Education. Jerry's research interests include mathematics education, including systems of internal and external representation, affect, engagement, and motivation in mathematics classrooms. In addition, he has interests in theoretical and mathematical physics, including foundations of quantum physics, nonlinear electrodynamics and quantum mechanics, current algebra and group representations, as well as mathematical learning and problem solving. There's quite a lot of interest. Welcome, Jerry, and welcome to you both. It's a very interactive and exciting presentation. I also want to introduce Lena as well, Lena Sanchez, who is a PhD candidate at Rutgers, and she is here. She's looking forward to interacting with many of you here as an experienced doctoral student. Some of you are just starting, so you might, hopefully she won't put you off. So she'll be here this evening and tomorrow morning as well. So please spend some time welcoming and talking with Lena as well. The session will be interactive. I understand there's going to be some videos, some reflections, and back and forth between the presenters, and then we will have about 20 to 30 minutes at the end for questions and answers. Right? So jot down your questions or discussion points. And those online, there's some issue with the text facility, so just email me if you wish to ask the presenters a question. Okay, thank you very much. Welcome. And over to, I don't know who.
Well, why don't you go to the next slide?
At 4:30.
So we also want to acknowledge Jakob Epstein, who's collaborating with us on much of this research, and say it's really a great privilege to work with such a fantastic group of people. Jakob is a social psychologist at Rutgers University, and so within our group we have some very interesting combination of fields coming together. Lena really was essential for preparing the presentation, and of course what we're talking about was based on a lot of work of a whole team of doctors. And thanks to Robert Murray and Gerald for valuable discussions too. So, next slide. So before we start with the discussion, theoretical analysis and so forth, we want to present some rather complex social and mathematical interactions drawn from classrooms we've observed. And at this point, just to look at them and form some preliminary impressions. And for that, I'll turn it over to Roberta, who's going to talk about the first episode.
I don't know how well you can see them, but in the corner over there, there's a young male student whose name we call Shay.
It's all or nothing.
And there's another female student whose name we call Dana. And you'll see them both. So we have these pictures so that you could be looking out for them in the video. So I'd like you to be thinking about them. They're both considered to have high social status, if you will. So we asked the teacher some questions about this, and you'll sort of see an interaction. Let me tell you a little bit about the math test that they were working on. Well, let me let you read it. You can actually take a. Can you see it back there?
Mm-hmm. Yeah.
It's a fairly common
I'm
type of. What does it say? Yes. Okay. So I'll tell you what. I'll read it for you. I'll read it. That thing at the bottom is a picture of a cow, by the way. It's
a great picture.
This, that's Bessie.
Cow?
That's how we grow them in Jersey.
Okay.
Jersey fresh. Farmer Joe has a cow named Bessie. He bought 100 feet of fencing. He needs you to help him create a rectangular fenced-in space with the maximum area for Bessie to graze. Draw a diagram with the length and width to show the maximum area. Explain how you found the maximum area. How many poles would you have for this area if you need one pole for every 5 feet? So this problem was chosen by the classroom teacher. It was part of the curriculum that she was given in the school. So let me tell you a little bit about the young man, Shay's work. They were all working in groups. The groups had between 3 and 5 students in them. Sometimes a kid floated in and out. He began working on the task alone. He said, you could make a lot of them. It could be like, wait. And then he started to realize that there could be many rectangles with a perimeter of 100 feet. He developed a method for constructing the rectangles with a set perimeter of 100, and his method involved finding the width for a specific length. He added the side length to itself. In other words, he doubled the length of the side, and then he subtracted the sum from 100 and divided the difference by 2. That was his method. You can see some examples. You can't see them well, but you can see some of the ones he initially drew. He realized that his other group members weren't following along with what he had developed, and he also realized that it would be a really long time for him to construct all the possible rectangles. So he developed, for very practical reasons, a method to do it, and he also took charge of the group mates. Here's something in what he did. So you can see in that first one, it's a 27 by 23, and he has a 25 by 25, a 24 by 26. So he developed a method where he successively decreased one of the sides. Okay, now the young woman who you saw, Dana, in the beginning, she had trouble figuring out what the word area meant and distinguishing area from perimeter. So she too took on the role of group leader. No roles were assigned to anyone, mind you. And she told the other students how to do it and what to do it. Unlike Shay, she was very careful about monitoring each one of the group members' progress. So she really looked over them and watched them closely. And when they thought they were finished, she would literally say, no, you ain't, and proceed to get them back on target. Okay, so she came up with one solution, and I'll show you that, which you can't really see very well, a 40 by 10. Once she had one solution, she decided to move on to the second bullet. She found an answer, and then decided that the third bullet rather, the one where you had to figure out the number of poles. Okay, so she, again, as I said, she didn't create many different rectangles, in fact, only one, and she didn't explore other possibilities. So now I want you to just take a quick look at a video. Whoa, whoa. Okay. Can I go back and start it again?
But we found all that up.